Hello and thank you for watching this video. This will be the first session for new employees of Cato Networks to help them better understand the challenges our customers are facing and the problems that we are actually solving for them. And that's the reason that they're choosing Cato. Before we start, we need to better understand the pain, the problem that our customers experience. And to do that, we need to talk in the same terminology as they do. So if I am a customer with many sites, with many branches spread around the world, headquarters, data centers, and I need to connect my users, it can be people at the branch working at their office, or people working from home, doesn't really matter. I want to connect them to the data center. So that connectivity is called the WAN, the Wide Area Network. So that's a private network that uses two different options, which we'll describe, in order to connect everybody to the data center, to applications, for people to talk over voice, to stream video, and so on. So traditionally, there are two options to do that, to connect those sites to the data center. The first one is using IPsec VPN, and the second one is using MPLS. So we're going to talk about them and better understand what the problem are. So in order to connect, let's start with IPsec VPN. What customers that choose that method are doing, they're placing a VPN gateway on two of their branches. Later on, we'll refer to them as next generation firewalls. But let's start, just call it a gateway. So basically, they are establishing a VPN tunnel, a virtual private network between their locations. They're using the public internet to do that, and they're encrypting traffic between the two locations. So if an employee that sits in this branch tries to access the data center over here, the traffic will be encrypted and secure, and they will be able to access any business information, while people from the outside will not be able to inspect it, to view it, and to steal, for example, customer name, credit card numbers, or any business data that belongs to this company. The problem with using the VPN is that in order to do that, they are doing it over the public internet. We call the public internet an unreliable and unpredictable transport method. And let's understand how the internet is built in order to really understand the pain that our customers are dealing with and why it doesn't really help or work for our customers. When I want to buy internet, if I'm a business or if I'm at home, a home user, a consumer, basically I'm going to my local ISP. It can be AT&T, Verizon, or wherever you are in the world, and you're buying internet. For example, 100 Mbps, megabit per second. That's the capacity that you're buying from your local ISP. Okay, we call this part of the network the last mile. The last mile is the connection between the physical site and your regional ISP. Okay? On the last mile, and the way it works, there are many challenges that causes bad performance. And actually, this is a very specific area where our customers are dealing with a lot of issues. And we'll talk about how we're solving it later on. When I buy capacity from my regional ISP, basically I'm buying the connectivity from my physical site all the way to their data centers, to their backbone. But if I want to, for example, to go into CNN.com, my ISP do not have a direct connection to them, and they need somehow to connect me. In order to do that, they're working with another global ISPs, maybe multiple ones, in order to establish this connection. Okay, so they need somehow to find a way to connect me to other sites or other locations around the world. We call this segment of the internet the middle mile. So these are very two important concepts. The last mile, which is the connection to the ISP, and then the backbone of the internet, the middle mile. and there are different issues between those two, and we're going to try to understand them. Let's start with the last mile. The business model that your original ISP is working on called capacity sharing model. So basically, if there are other offices in the street or for example at your neighborhood where you buy internet, basically they're all connected to the same 100 megabit that your ISP physically has, and they're selling it, for example, to 10 different customers. The exact same 100 megabits are being shared between multiple offices in the building, with maybe multiple sites on the street, and basically they're all sharing, connecting to the same place, and then going to the same, over the same physical equipment all the way to the ISP. The reason the ISP are doing that is for business reasons. They want to spend less on infrastructure and make more money. And the reason that it actually works is because when we use you don't use the internet all day long. And even when you use the internet, it's not that you're using 100 megabits all the time. So based on mathematical algorithms, they have the ability to project that most of the time, 99% of the time, your internet will work very well. But there are some times where many people, and we actually can experience at the rush hours, or maybe at some specific hours at night when we go home, the internet is not performing as good as we used to. And the reason is because everybody are now using it and trying to use the same 100 megabit. What happened is that packets are starting to drop. Okay, think about it like a hose of water. You can spill water into it. At some point, it will start pouring out, and that's called packet loss. And when a packet loss occurs, basically all the users in this segment need to retransmit and ask for the data again, and it causes performance issues. A good example for it, when you're watching a YouTube video and you see that it's buffering. That's one example for that can be caused because of packet loss. So there is a direction called last mile, but basically it's not guaranteed because we're sharing it with other companies or other customers of our regional ISP. On the middle mile, there are other issues. One of them is packet loss. The second one is latency that is caused because our ISP do not control the entire internet. They are working with other providers in order to access some places over the internet, and the route that they are using is unpredictable. Basically, your ISP, it can be anyone, BT, AT&T, Verizon, where they want to access some location when they don't have a physical network, they need to work with third parties, other ISPs, and in order to do that, they're just buying from them capacity, and they're just throwing this traffic to their network. The problem with that is that they do not control it. The second they are dropping your traffic from your ISP A to ISP B, C, or D, that's it, you lost control. So one packet, a specific set of data that you're trying to get, can go over ISP B, which is very fast, and another one can, because it's specific time of the day, this ISP is more busy because the ISP pays more money in order to move traffic, so they want to hear it's cheaper at this specific time of the day, they will try to move it over D, and then D will drop it to E, and so on, so it can take a longer route. So we call the time it takes a packet to go from point A to point B the latency. The latency is the time it takes the packet to travel to the destination. So we want obviously the latency to be as short as possible. Because the internet is unpredictable, it can have different hours of the day, and it can happen on different hours of the day, and different routes can be taken, so more latency will be increased. Another problem is when I move traffic from one ISP to the other, here in those locations there are a lot of packet loss because these are congestion areas, so packets can also be dropped here. Again, if I'm sending a packet and it's being dropped here, and now I need to request it again, and that's a problem of the middleman. Let's take a look about a very nice website that shows how the internet backbone looks like. What we see here is a very nice website that actually shows how the internet is built. You can see here all the carriers that actually connects continent and countries to one another. This is the internet actual backbone. We talked about the fact that the middle mile is built out of multiple tier 1, tier 2 carriers that has business relations to provide connectivity to different regions in the world. So this actually gives a very nice visibility to how it looks like. We can drill down and see on every country which relation it has and how it actually go out to the rest of the internet. And for many people it's shocking because they think about the internet as kind of a virtual thing, that's something that actually works, but underneath the underlay we see that there are a lot of companies, private companies, that mostly care about their business, making money, and that's the main reason that the internet is unpredictable, as I described earlier. So now we understand that the internet is not just virtual cloud-ish. It's actually wires that connects physical sites to other networks and to another physical sites. And this is another ISP and another last mile. And when I want to connect my HQ with a branch, there are two last mile where there is a lot of packet loss issues around the last mile. And then there is the middle mile, which actually connects my sites together, which is unpredictable. And in general, end-to-end, it causes an issue of unpredictability. If I have applications which are latency sensitive, like voice, for example, when I'm talking on the VoIP telephone, I want the call to be very smooth. Otherwise, we'll hear this jitter, this lagging in voice that actually being caused because of latency and high packet loss along the way. And that's something that many organizations cannot tolerate for their business application, for their latency sensitive application. So they're looking for another solution, and this other solution is called an MPLS network. So we said there are two options. The first one is VPN over the public internet. I'm placing two gateways and connect them over the internet. The second option for companies is to use the MPLS. MPLS network is a point-to-point. Basically, I'm buying a very expensive link from one site to the other. I will go to AT&T and ask them for this specific MPLS network. The problem here is that MPLS is very, very expensive. This is the main reason companies hate or want to get rid of their MPLS. Okay? This network is very high quality. When I'm buying 5 megabits, and the reason I'm saying only 5 is because this is actually the capacity that most companies are buying, 5, 10, 20. They're buying very low bandwidth because it's so expensive. But when I'm buying this capacity over my MPLS network, I get SLA. It means that the ISP guarantees that the latency, the packet loss, and also what happens if something happens to the line and, I don't know, the line is being cut. It will, for example, give me 4 hours before they fix it, versus the internet, when there is no predictability. It can take a few days before someone will fix my problem, and that's another reason companies are buying the MPLS. So companies want this predictability and assurance of performance, and they are paying a lot of money for it. Another problem of MPLS is if I have a new branch that, let's say, I'm expanding to a new country, now I need to deploy a new MPLS network, and it takes between 3 to 6 months to deploy it. That's a challenge, again, another challenge for a lot of customers. It's very, it's not flexible enough for them to connect new sites, increase and decrease capacity, and so on. They're talking usually about long contracts of 3 to 5 years for the MPLS, and at the end of the day, they're getting very low capacity. So, kind of to summarize the challenges, the differences here is that MPLS is a very high quality network, but it's very expensive. Versus using the internet, which is cheap, but unpredictable. And these are the two options that most companies today need to choose between. So now I want to talk about the new market that started evolving several years ago and now is at its peak. Cato is actually playing in this market, which is called SD-WAN. SD-WAN, software-defined WAN, is a market that comes to address with the challenges of the MPLS is too expensive versus the internet is not good enough, and try to mix those two worlds together. So if I'm a company and I have an MPLS network, and let's say I have only 10 megabits connecting those two sites. So now I can go and I can buy SD-WAN solution, and I can add additional internet VPN links on top of my MPLS. So I can buy a BT, another 100 megabits, and another 100 from Verizon in this example. So now my SD-WAN device will steer traffic over all the available transport that currently available to it. So I can decide that voice and video traffic, which is more latency sensitive, will travel over the MPLS, versus my email and other business application will go over the public internet over VPN. So actually SD-WAN, its essence, allows companies to expand and augment their MPLS capacity with the cheaper internet links, while they need to keep the MPLS for the more sensitive, latency-sensitive application. So they have high performance, which is kind of expensive, but high performance link with not as good performance like the MPLS, but still good enough for other applications. So instead of buying more capacity for the MPLS, they are moving to more links, and the SD-WAN edge devices will kind of steer traffic on everything, so they will measure the latency and packet loss at every single second and decide, based on the policy obviously, where to steer the traffic and which links to use. So voice and video will use the MPLS, email will go over the first link, and the CRM, I don't know, will go over the third one, because that's the policy the organization set. So this is kind of a very basic concept that we need to understand, that companies want to connect their sites, branches, headquarters to one another. They can either use MPLS or VPN. Both of them are not optimal, and today they're going into SD-WAN market, into SD-WAN solutions, in order to kind of play on everything. And we'll talk later on what's the difference between Cato and other SD-WAN solutions, but one of them is that SD-WAN use the public internet for the VPN, which is unpredictable, as we explained. So, and we're doing it a bit different. Another issue that our customers are looking at when they approach us is when they want to connect their data center in the cloud. So if I'm going to Amazon AWS or to Microsoft Azure, meaning that I'm taking my business applications from the traditional physical data center and now I'm placing it in the cloud, I need somehow also to connect those branches and headquarters to those locations. So SD-WAN kind of today evolved into also addressing this challenge, connecting all those locations together. And the last thing is mobile users that also needs to be addressed. It's very unique to Cato, but I'm talking about it here as a problem. So I also want to connect mobile users to my physical locations, to my cloud data centers. This is a very unique solution to Cato. Most SD-WAN today do not talk about mobility as part of the problem, but we do. So it's an issue. I have hundreds of mobile users using their iPhones, using their laptops, wherever they are in the world, and they now need the same access as they were sitting at the headquarters. So this is the first part of our video, talking about connectivity and how do I create a WAN around the world for multiple sites and users. Thank you very much.